So another astronomy question here, and for this one we need to use Kepler's third law of planetary motion, which is that the time period squared is proportional to the distance from the Sun cubed. So that means that the distance to the Sun cubed divided by the time period squared gives us a constant. And that will be the same constant for all the different planets that we're looking at in this question. So we've got the nearby planet, which is 0.4 astronomical units away. So we're going to do 0.4 cubed, and we're going to divide that by the time period squared. So it's 3 days squared. We don't need to change any of the units here to meters or seconds because we're using the same units in both examples. So the more distant planet has a time period of 24 days. So when we put those numbers into our equation, then here we've got this is equal to a constant, and this is going to be equal to the same constant, so that's how we can equate them in this equation. So you should be able to do these calculations in your head or on scrap paper while you're doing your PAT test, just to so they're not too complicated. It's just a matter of just some long multiplication there. So that's what we're doing here, just plug in those numbers in there. And what might be a little bit trickier is just finding that cube root. So once we plug all the numbers in, then what we've got is this cube root of this number that includes some decimals. So the way that you could go about trying to work out what the cube root of that is to say that, well, 1 cubed is equal to 1 and 2 cubed is equal to 8. So they're the sort of common cube numbers that we should know. And 4.096 is somewhere in between those. So immediately we can rule out answer D and answer C because neither of those are between 1 and 8. So 16 is obviously higher than 8, and 1 is, it's obviously the same as 1. So we've got two possible answers. It's either A, 1.6 astronomical units, or B, 3.2 astronomical units. If we do 1.6 cubed, then we do get 4.096. And if we do 3.2 cubed, then we get 32.768. So that's clearly wrong, and 1.6 cubed is the right one. So answer A is what we're looking for there.